Hey guys, today's Thursday, April 30th, last day of April, and we're finally about to be done with Goal 7. Today we are learning about extreme value theorem. Basically what this says is that the derivative of a function is always equal to 0 at extreme values. So extreme values, remember, are max or min values. So at these max and min values, we know that the derivative would always equal 0. And wherever these points are where the derivative equals 0 are called critical points. And remember, derivative equal to 0 would mean that the slope of a tangent line would be equal to 0. So slope equal to 0 means it's a horizontal line. Let's take a look at an example of a graph. On this graph, you can see at these two pink points, which would be relative maximum and minimum points, meaning they're higher or lower than the points around them, you can see that the tangent lines at these points are horizontal lines. However, if we look at just some random point over here, like this green point, the tangent line is not a horizontal line. And this green point is not a relative maximum or minimum compared to the points around it. So notice when it is a relative max or min, the tangent line is horizontal, which means the derivative is 0 at this point. You also need to look for some other points as well. So if the graph or function is only being used on some interval, the endpoints also have to be included as critical points. So for example, let's say that we were only looking at this function on the interval from -5 to 7. That means that we need to include -5 and 7 as critical points. Notice that this point on the graph at -5 and this point on the graph at 7, if we're only inspecting the graph between the two yellow lines, both of these points at -5 and at 7 would be extreme value points. At 7, notice within the yellow lines, this y value is the highest y value out of any of the y values within the yellow lines. So don't forget to include endpoints as critical points. Once you find all your critical points, you're going to evaluate the function, which means find the y value for every single critical point to see which one gives a maximum or a minimum value in the function, and then interpret your answer. So let's do an example together. This says the height h in feet of a car traveling along the track of a roller coaster can be modeled by this function. Whoops. On the interval 1 to 12, inclusive, where time t is given in seconds. Find the maximum and minimum heights of the car. So I know that the first step is to find the derivative of this function. However, I like to just get a visual to help me out. So what I did was I plugged in my function to my graphing calculator. You can see what I did here. And just looking at it on a normal window, I didn't see much. Just looking at it on a normal window kind of looks almost like a quadratic function. But I know that this is a cubed power, the highest power is cubed. So I know that this shouldn't just be a parabola shape. So what I did was I changed my window. I changed my x's to be 1 less and 1 greater than my interval. Remember, my interval was from 1 to 12. So I made my minimum value 0 and my maximum value 13. I left the x scale as 1 since 1 to 12 isn't that big of a range. For my y minimum, I know that the roller coaster is not going to be a negative height, so I set my y minimum to 0. For my maximum, I first tried 30, but it still didn't show the whole function. Next, I tried 50. That still didn't show the whole function. So I finally just decided to do 100, and this worked. It showed the entire function. And since I was going all the way from 0 to 100, I decided to use a y scale of 10, just so I would be able to see my scale on my y-axis. So let's see what the graph looks like then. So notice the x-axis is time in seconds. The y-axis, remember, represents the height of the roller coaster in feet. And we are only interested in the part of the graph that goes between 1 and 12. So we're actually cutting off the first unit and the last unit since we added those on with our window. But just so that we could see a good view, we wanted to include them. So I'm pretty sure the maximum value is going to be somewhere here. And the minimum is going to be probably one of the endpoints. Now let's go over how to actually find these algebraically. So the first step, like we said before, is to find the derivative of the function. So we have our function, h of t was, remember, equal to negative, whoops, this is not it. What's the next one? Oh yeah, this is it. Negative 1/3 t cubed plus 4t squared plus 11/3. So in order to take the derivative, these are multiple terms, so I'm going to go term by term. For the first term, it's a power, so I'll use power rule, bring down the power, subtract 1 from the power. Same for the second term, bring down the power, subtract 1 from the power. For the third term, however, since this is a constant, the derivative is just 0. So now I'm going to simplify. Negative 1/3 times 3 gives me negative 1. 3 minus 1 is 2. You can follow along from here. Okay, I don't really need to write the first power, so I can actually just erase that. Step 2 is to find my critical points by setting the derivative equal to 0. So I'm going to set 0 equals negative t squared plus 8t. Now if I want to solve this, since it's a quadratic, I'm going to have to look at factoring. Or you could use quadratic formula on your calculator if you have that programmed in. That's an option too. So I'm going to factor out the greatest common factor first, since that's always the first step in factoring. I'm left with negative t plus 8. This is completely factored now in just one step by taking out the GCS. Once you have it factored, you set each factor equal to 0. And solve. This factor is already solved. 0 equals t, that equation is solved. The other equation, however, I just need to add t on both sides. So I get t equals 8. Now notice 0 equals t is not included in our original interval that we're inspecting our equation. So we're not going to include 0 equals t as one of our critical values. Step 3, we evaluate the function for all critical points. So remember, our endpoints are also critical points. So we need to find f of 1. Sorry, it's not f. What's our function called? H of 1. We need to find h of 8. And we need to find h of the other endpoint, which is 12. Now, since I already have this function plugged in and programmed into my calculator under y1, I went ahead and made sure that my table is set up as independent variable on ask and dependent variable on auto. And then I could plug in my 3 values for the x value, and I can see my heights right here rather than going through and plugging these numbers in one by one. So I see that h of 1 is equal to 7.3 repeating, h of 8 is equal to 89, and h of 12 is equal to 3.6 repeating. Finally, step 4, I need to tell the reader what this means. So I was looking for the maximum and minimum. I can tell that this is the biggest number that I received. And remember back from the graph, I was thinking that the maximum was probably going to happen somewhere around 8. The minimum number that I got out of the function for my critical points was 3.6 repeating. So I know that is my minimum value. So now to explain this, I'm going to say the maximum height of the roller coaster is 89 feet. It reaches the height after 8 seconds. Similarly, the minimum height is 3.6 feet approximately. And happens at the end of the ride after 12 seconds. That will be your final answer. Okay, I have another one that I want you to try on your own. So read this problem, pause the video, and see if you can do it by yourself first. Okay, here is the correct answer for this problem. Here's steps 1, 2, 3, the beginning of step 3. This one I worked out all by hand so you could see. Here's the rest of step 3. So I plugged in each of my critical points. And then to interpret my answer, here's a sample of what you could say. It doesn't have to obviously match that word for word, but it should be giving all of that information somehow. Okay, your homework for tonight is on page 772 again. You are doing numbers 49 and 60, and reflection question for tonight is number 68 in the book. Make sure you're really thinking about this one and writing your own answer, please, guys. Thanks. Have a good day. See you tomorrow. Happy almost Friday.